Hello. In today's class, we will be taking up this problem on internal VLS. Fine. So this is a problem from epicyclic gear trains, and we can see the statement only is given to us. Okay. So based on the statement, we'll have to draw the diagram here. So there is an internal wheel B. B is shown in yellow color. So B is, you can see, is shown with yellow color, and the shaft is also keyed to the same thing, whereas C is a different wheel which is slightly larger because it has more number of teeth, and when these two gears are meshing with a set of compound wheels. Compound wheels are D and E. So for D, the number of teeth have been given to us that I have shown here in this, and for D, for D the number of teeth have been given, whereas for E number of teeth have not been given. So these are the number of teeth for D. So you can see D has 28 teeth and gears with C. You can see it's gearing with C indeed, and E is gearing with B. He has not provided us the number of teeth for E, and then they are all coaxial. If the wheels have the same pitch, this is one additional information that is been given to us. They have the same pitch. Shaft A is making 800 rpm, which I have you can see noted down over here. What is the speed of shaft F? Now F is keyed with the shaft, the gear B, the wheel B. So if we find the speed of the wheel B, we will automatically get the speed of the gear. So now, in order to solve this problem, we'll have to make a table wherein we have to mention the condition and number of the speeds. We have to write down the formulae for speeds of different things. So we'll always start with the speed of the arm. So in this case, arm can be written as A. This is the disc. Okay, so the disc has been shown in dotted form. You can see the disc and the shaft are keyed together. So that's what we are going to take first. Next, we are going to take this yellow shaft, which is the wheel B or the shaft F. Both are compounded together, keyed together, so both will rotate with same velocity. Now this wheel is connected with E, so we'll have to take that next. Speed of E, and E and D both are rotating together. So when you find E, it will be same as D, and that finally connects to C. So this is the table that we need to develop. Okay, so first we will keep it fixed, and one rotation we will give to B. So when arm is fixed, the speed of this is 0, and for B we are giving one rotation. For B we are giving one rotation. Now we have to find how many rotations these other two wheels are going to execute. So for that, you can see that B is connected with E, so NE by NB will be equal to TB by TE. Okay, so this is the relation we have to use. Now, because the meshing is happening internally, this negative sign will not come, it will just be positive. So now NB we have assumed it to be 1, so NE will be equal to TB by TE, but we don't know the value of TE. In order to find the value of TE, we'll have to do some extra calculations. So let's say diameter of B by 2, diameter of B by 2, which gives us this length, minus this radius. Okay, diameter of B minus this radius is what we need to do. So minus diameter of E, diameter of E by 2. So this is equal to the length, let us say this point, let's call it as O. So that is equal to AO. Now the same length AO will also be equal to diameter of C by 2, that is radius of C, minus the radius of this one, that is d, so diameter of d by 2. Okay, so both are equal to the same length. Okay, so that means they will both be equal. Fine, so if we remove this from the center, these two will be equal. Okay, so using this information and substituting the value for module, because module of all the gears will be the same, so module can be taken common, and we will get, of course, module by 2. Let's take common, and module by 2, if you take out common, you will get number of teeth inside. Okay, so this will be equal to again the same module by 2 into number of teeth on C by number of teeth on D. So now module is same for all of them, so it's going to cancel, and we're left with the relation between teeth. Okay, in this case, this is the teeth on E. So teeth on B is 80 minus teeth on E, we don't know. Teeth on C is 82 minus teeth on D is 28. So that will allow us to find the value of TE, which is 80 minus 82 plus 28. So that gives us 26. So PE value is 26. So let me write here 26. So now that we know the value of TE, we should go ahead and substitute it here. So one rotation, when we are giving it to B, NE and D will rotate by this value. Fine. So N TB, which is 80, divided by TE, which is 26. So if we want to simplify this, it becomes 40 by 13. So 40 by 13 is the number of rotations that this compound will execute. Next, we have to find NC. So NC, you can see C is meshing with D. So NC by ND will be equal to TD by TC. Once again, this is going to be positive. It's not negative because the meshing is happening externally. Then TD and TC, both values we know. ND, we have to substitute from over here. Okay. So this, if you send it to the other side, we will get the value of NC as, TD is 28 divided by TC is 82. So 28 by 82 into ND being 40 by 13. So okay, we'll have to simplify this. Let's go ahead and do this in the calculator. 28 into 40 divided by 82 into 13. So we want it in wavy format. That's a big one. So 560 divided by 533. Okay, so this is the value. Now let us say arm is rotated by X rotations. Arm is rotated, sorry, not arm, we are rotating the first one, that is B. B rotated by X rotations. If B is rotated by X rotations, X gets multiplied to all the values that we have here, and same here. And then arm is rotated by Y rotations. Arm is rotated by Y rotations. So Y gets added to all of them because arm is the one on which all the other gears are situated. So it's going to add up. Okay, same thing plus Y. So these are the final formulae. These are the final formulae that we can use. So now NC has been, we have been told that NC value is fixed, it is constant, and that NA is rotating with 800 RPM. So that means Y value is 800, and then NC is, okay, NA is equal to Y. NC, we know it's 560 divided by 533, X plus Y. This value has been told to be 0 because it is fixed. Now using this relation we can find the value of x, and that will be minus 800 into 533 by 560. So that comes out to be 761.43. Okay, in negative direction. That means x rotates in negative direction to the direction of the arm. If arm is rotating clockwise, this will rotate anti-clockwise, and so on. So this also is in RPM. Okay, so we have been asked to find the speed of f. F means we have to find the value of x plus y. So nf will be equal to x plus y, x being minus 761.43 plus y being this much. So that gives us value of 38.57 RPM. Now this RPM is in the same direction as the arm, same as R. Okay, so that's it for this particular session. If you have any doubts with this one, you can let me know in the comment section below. If you want more such questions to be solved, you can share that as well. But the initial tension, which was 2000, will be same as this. Okay, so actually the average of these two tensions will remain the same as the initial tension. So that's what we have to use. And then the coefficient of friction is given as 0.3. You can say I've written it down. Angle of lap of the smaller pulley, you can say it's given as 50 degrees. And then radius of the smaller pulley is given, that is 200 mm, and the RPM it is rotating with is also given to us. And we have been asked to find the power. Okay, and we know the formula for power is 2 pi n t by 60, and this t being the torque, that t being the torque. So that t will be equal to T1 minus T2, that is the difference between the two tensions, multiplied with the radius. So this is the value of the torque. Speed is given to us, so we'll be able to find power. Yep. And here we need to first find the values of T1 and T2. Radius is given to us, but these two are not known. So in order to find T1 and T2, we'll have to use the two relations, that is T1 plus T2 by 2. The value is given as 2000, and then we also know another relation, that is T1 by T2 equals mu theta. So these two equations can be used to find the value of T1 and T2, which can be then substituted over here. Okay, so this is how we're going to solve the problem. So let us start solving it. So we'll have to start from the reverse direction, of course. So first equation we have already written. The second equation is T1 by T2 equals e power mu, that being 0.3 into theta. So now this theta that is given to us, we need to convert this into radians. Okay, so pi by 180 degrees we need to multiply. So that will give us the value in radians. So let's see what's the value given over there. 50 into pi by 180, 0.87. That's the value we need to insert over here. So we will get the value of T1 as this value into T2. So let's find that value. So e to the power 0.3 into 0.87. So 1.30, 1.3 times T2. So this we need to substitute over here to get the value of T2. The T2 will be 2 into 2000 minus T, okay, 1. T1 we can substitute anyway. Okay, so Let's keep T1 on this side itself. T1 plus T2 equals 22,000. So T1 is 1.3 T2 plus T2, that gives us 4,000. So adding this, we get 2.3 times T2. So T2 will be 4,000 divided by 2.3, 1739.13. So this is the value of T2. Substituting this back here will give us the value of T1. The T1 will be this value multiplied with 1.3, that gives us 2260.87. So this is in Newton. So these are the values of T1 and T2. So now that we know the values of T1 and T2, we can use the torque formula. So torque will be T1 minus T2 multiplied with the radius. So 2260.87 minus 1739.13, multiplied this with the radius, that is 200, but this is given in mm, so we'll have to divide it by 1000 so that we get the final answer in Newton meters. Let's find this out. So 2260.87 minus 1739.13, this has to be multiplied with 0.2. So 104.35. This is the value in Newton meters. So this is the value of torque in Newton meters. Let us see what else is asked. So he's asking us to find the power. So now that the torque is found, the final step remains to find the power. So let's go ahead and find the power. Power is 2 pi n t by 60. So this t is the torque. So 2 pi into RPM is given as 500 into torque we just now found 104.35 divided by 60. So that value will come out in watts. Let us see how much it is. 2 times pi into 500 into 104.35 divided by 60. So 5463.75. So this will get in watts. So that is the value of power. So this is the solution to our problem. So this is the solution for A bit. Next we'll have to solve for the B bit. Plate clutch, single plate clutch is supposed to transmit 25 kilowatts, rotating at 3000 rpm, and we have to find the inner and outer radii for radii of frictional surface with the coefficient of friction is 0.255. All the data I have written down over here. R1 and R2 is what we need to find, and we have been told to use the theory of uniform wear while solving this problem. Now when it comes to uniform wear, we know the derivation is somewhat like this. We can pause and take a look at it if you want, and that gives us the value of R main value as R1 plus R2 by 2, and I think this will be helpful to us in solving this particular thing. So R1 and R2 is what we are supposed to find. The ratio of R1 by R2 has been given to us. R main is this, and R main value is utilized in the power formula. So power, not power, I think it's just the torque. So the total torque that we get is W into mu into R main. So, and torque can be found from the power relation, that is 2 pi n t by 60. So here the value of n has been given to us and power is given to us, so we'll be able to find the value of torque. We can substitute that over here. Then over here W W is again not given. So in order to find W, we have to use the maximum pressure theory. So maximum pressure theory we have to use. We get the value of constant as W by 2 pi R2 minus R1. Here we know the maximum power. So I think somewhere R into P equals constant. This is the relation we have to use. So R1, okay. So R1, let us say, is the smaller radius, R2 is the larger radius. If R1 is less, P will be maximum, and if R2 is less, P will be minimum. So both of these will result in the same ratio. So now here we can use the relation, the ratio of R1 by R2, maximum by minimum. We will get the ratio of maximum by minimum. Oh, we're supposed to find, we're supposed to use this. Ultimately, we are interested in finding W. So how are we going to find the value of W? So maximum pressure is given to us. All right, maximum pressure is given to us. We can find the minimum pressure, right? Yes, once we find all these values, we'll be able to define K, and the value of K is given by W by 2 pi R2 minus R1. So now here we get another relation for R1 and R2. So I think utilizing this and utilizing utilizing this and the ratio R1 by R2, I think we'll be able to find R2 and R1 both. So we'll have to go by this order. Okay, so let's start solving it. We have to solve, of course, in reverse direction. So R1 P max equal to R2 P minimum. So R1 is the smaller one, so this has to be 2 by 1. Okay, yes, so this is 2 by 1. So here again it's going to change. So R1 by R2 into P max. P max is 0.1. That will be equal to P minimum. So P minimum will be equal to 0.1 into okay, so this will come in denominator, 0.25. So we get 10 by 125. This is the ratio for R1 by R2. How are we supposed to find this? Alright, so we need to find another relation. Let's take the power relation. So power is 2 pi n t by 60. And what is torque? Torque is W into mu into R main being R1 plus R2 by 2. So here n is known, omega is known, and mu is also known, as well as power is known. So let's substitute all this. 25 into 10 power 3 n watts, that's equal to 2 pi into n is 3000 by 60 into mu 0.255 into r1 plus r2 by 2. R1 r2 both are not known, or else we could just substitute over here. So r1 12.5 times r1 equals r2. So r2 we can substitute here and we can find the value of r2. So this will cancel. So 25 into 60 divided by 2 pi 3 0.255. This is equal to r1 plus 12.5 r1. So r1 value we will get here. And then we have to divide one more thing here, that is 13.5. So 23.12. I think this will come out in mm. Total load is not given. Yes, we have to use this formula here to find the total load. That's not defined completely. We are getting stuck here somewhere. This is equal to constant k value is W by this. How to get the value of k stands as the question. Talking of over here, so that is equal to the multiplication of radius and maximum pressure, and that value we found that it was equal to this during the derivation, and that's the equation we have to write down over here. Then R2 R1 should be reduced to R1 by using the ratio relation over here, substituting that, and that will finally give us a relation between W and R1. Okay, so this should next be utilized in the equation for power. The power relation is 2 pi n by 60 times the torque, and torque is given by this particular relation. So going back this, you can see that n value is 3000 divided by 60 into W. Now W is to be replaced by all this. Okay, so it's becoming a very big equation. So 2 pi into 0.25 into 0.1 into R1 square. Okay, so that is W. That should again be multiplied with mu, that is 0.255 into R1 plus R2. R2 should be substituted, so 2.25 times R1 we will get over here. that is divided by 2. So this entire thing, when we multiply, we will get r1 cube, and r1 cube will be equal to some constant. So let us find r1 cube will be equal to how much. So let's come back to this relation. So 25 into 10 power 3 and into 60 into 2 divided by, so 2 into 5 into 3000 into 2 into again pi into 0.25. Okay, into 0.1 into 0.255 into 2.25. Oh, it's a long list. This is the value 1765.95. So this will give us the value of r1. So this okay, let's take this cube root of answer, that gives us 12.09. So I guess this is going to be in mm. So r1 is this much, so r2 is going to be 1.25 into 12.09, 15.11. So this is a very small value, I guess. We again ended up making some mistakes over. I'm not really sure about that. It seems to be the correct one itself. Not really sure still कि ये correct answer है कि नहीं. Let's try substituting this value in Newton per meter square. We do that. That value is in denominator. To 10 power 6. Okay, so अभी थोड़ा सा ठीक लग रहा है. With this one, when we do it like that, is giving us the value in 0.121 in meters. (0.121 meters means 121 mm. So this appears to be correct. (151.25). Okay, so these values appear to be correct. So before substituting, we need to convert this into SI units. Okay, so that will be the correct answer. This much thickness is to transmit a power from the pulley of 1 meter diameter, which is running at 500 rpm. The angle of lap joint, that is the angle of contact, is this much, and the coefficient of friction is this much. The mass density of the belt has been given to be this much. Maximum permissible stress should be limited to this. It should not cross this, or else the belt is going to break. So you can see I have written down all the given data over here, and on the right side, this is, I'm calling it as the formula tree. Okay, so this formula tree gives us an idea about how to actually solve this particular problem. Okay, let us keep this aside here. So we are interested in finding the power. Power formula is given by this value. N value is given. T, the torque, is unknown. Now torque has another formula which is related to T1 and T2. R is given. T1, T2 are unknown. And there we have another relation for T1, T2, that is the formula for friction with the coefficient of friction. And then we have another formula that is for total tension, total maximum tension. And total maximum tension includes the centrifugal tension. Both are added. That should be within this limit as defined by the maximum stress, and that leads us to the final given data. So this question, we need to solve it in the reverse order. So we have to start at the bottom and go up, and finally we reach the ultimate thing that we are supposed to find over there. So let me keep this aside a little, and we're going to use this space over here for calculations. So first thing we have to do, we have to find the velocity. So velocity is 2 pi n by 60 times the radius 500 divided by 60 times radius. Diameter has been given. We need radius 1 by 2. We can put it. Let's quickly calculate this over here. Right, so 2 into pi into 500 divided by 60 times 2, 26.18. So this is in meters per second. That is the velocity of the belt. Now using the velocity, we need to find the centrifugal tension. So that is rho a v square. Okay, actually it's mv square. M is nothing but rho into area of cross section. A is this area over here. Right. So we know the value of W and T, which we can substitute and find it. The rho is 1000. Area will be W into T. That's okay. So I think we have to convert this as 0.15 and 0.01. 0.15. We have to convert this to meters. Okay, before substituting. And that's what provides us these values. So that will give us the centrifugal tension. So 1000 into 0.15 into 0.01, it's minus, and into 26.18. So 39.27. Now this is centrifugal tension and its value will be in newtons. Next step we have to take is to find the total tension. So total tension will be T1 plus Tc, and that's limited with the formula sigma max times the area, again W into T. Okay, so Tc value we know it, and T1 value we need to find. So send Tc to the other side and we will get it. So this is 3 megapascal. Mega is 10 power 6. It is in SI units. W, as I told here, 0.15. T is 0.01. And then TC we need to send to the other side. It becomes minus 39.27. Okay, so that, let us see what we get. So 3 into 10 power 6 into 0.15 into 0.01, that is giving us Still a pretty large value. Minus 39. Oh, let's just be sure of if we are doing any mistakes, because if a mistake happens at this level, it's going to be very difficult to manage. So the mistake happened over here. This is supposed to be a square. We didn't consider that square. We don't need to do that. The square needs to be considered over here. So when we take up that square, the value here will be very different. The same thing has to come over here. So that's 1028.09. This is in newtons, and the same value should come over here, and that we have to take over here. All right, so that gives us 3471.91 in newtons. So that is the tension on the tight side. That is the tension on the tight side. Having known the tension on the tight side, we should proceed to find the tension on the slack side. So for that, we will be using this relation, T1 by T2 equals e power mu theta. So T1 value we know, 3471.91, and T2 we don't know, send it to the other side. E power, this value will come over here, so e power 0.3 times theta. Theta, even though it's given at 160 degrees, we should not take it in that way. We have to convert it into radians. So this is the value that we have to take. So let's quickly calculate that value. 160 into pi by 180. So that's 29 point this. That is the value we need to use over here. So 3471.91 divided by e power bracket 0.3 into answer. So this is the value we're getting, 1502.22. Okay, that's the value of T2. Okay, so what do we write over here? 2.79 is added. 2.79. This is in radians. 2.79 in radians. This is the value we have used over here. Okay, so T2 value we got after calculation is 1502.22. So T1, T2 both we got it. So both can be substituted over here to get the value of torque. So torque will be T1 minus T2 times the radius. So okay, let's just feed it directly over here. 3471.91 minus 1502.22. That should be multiplied with the radius, that's 0.5, half of a meter. 1 meter is the diameter, so 0.5 will be the radius. So that gives us 984.85. This is in Newton meters. This is in Newton meters. And finally, now we can go ahead for the maximum power. This is when we can go for the maximum power. The relation is 2 pi by 60 into the torque. Okay, so 2 pi n is 500 rpm, and torque is 984.85. okay, so 2 into pi into 500 into 984.85 divided by 60. Wow, oh, 51566. So this we will get it in watts. So if you want to convert this into kilowatts, we will get it as 51.57 kilowatts. So this is the maximum power. So hope you have understood this particular problem. If you have any doubts or didn't understand a particular step, let me know. Also, let me know what you think about the formula tree, which is a method that I developed while teaching the students. Is it useful? Is it not? Let me know. Thank you. Next, we have another problem from October 2020 over here. So we have two parallel shafts that are connected by spur gearing with approximate center distance. So center distance that is given to us here is an approximate distance. If one shaft is running at 120 rpm, so let's take this as N1, 120 rpm, and the other is running at N2, that's 360 rpm. We have to find the number of teeth. So T1 we need to find, and T2 we need to find. Module has been given to us. Module, we know module is nothing but diameter divided by number of teeth. So this value has been given to us as 8 mm. Also find the exact center distance. Okay, so let's go ahead and see how to solve this problem. Fine, so let's say we have one gear and the second gear, and the center distance approximate distance has been given to us. We are supposed to find the exact distance. Okay, so first let us go ahead and find the diameters. Fine, so we all know that the ratio of speeds, the smaller the diameter, higher will be the speed. So speed is inversely proportional to the diameter. So N1 by N2 will be T2 by T1. So using this, we get 120 by 360 equals D2 by D1. And we know the center distance. Center distance is given as 600. So center distance means the sum of the two diameters. That means D1 plus D2 has been given as 600 mm. Okay, so that and this both we need to use in order to find. So this just simply reduces to 1 by 3. So 3 times D1 equals D2 is one relation we get. This is equation 1, equation 2. So we need to just solve them by substitution. So D1 plus 3 times D1 equals 600. So D1 equals 600 by 4, which gives us 150. Let's say this is in mm. So D1 is 150 mm and D2 is 3 times of that, so 450 mm. So we may think that the diameter of D1 and D2 have appeared, so our task is over, but that's not the case. Fine. So what we need to do now is to find the number of teeth, and finding number of teeth is not a simple task. So let's find the number of teeth on first. So T1, we have written the formula for module over here. Module is diameter by number of teeth. So if you want to find the number of teeth, that will be diameter divided by the module. So if I want number of teeth on 1, it will be first diameter, that's 150 divided by module, that is 8. And now this is where the problem comes up. So 150 by 8 is given 18.75. But number of teeth cannot be 18.75. It can be either 19 or it can be 18. It cannot be in between somewhere, and that's the big problem for us. So even though the velocity ratio we need to maintain as the same, that is not to be disturbed. We can disturb the center distance. Center distance can be disturbed, but not the velocity ratio. So in order to maintain the velocity ratio, what is the thing we can do? We can either go for 18 or we can go for 19. 19 is an odd number, and I think it's not suggestible for us to go for a gear which is having odd number of teeth. So let's go with 18. So if we go with 18 as the number of teeth, then the diameter one is going to change. So T1 into M. So that is, if you are taking 18 times 8 will give us the actual diameter. 18 times 8, 144. So instead of having 150 as the diameter, we have to take this as the diameter. So this is the exact value of T1 diameter. And D2, because the velocity ratio we want to maintain the same, so this relation is still applied, and D2 is 3 times of T1, that is 144, and that is 432. Okay, so this is the exact distance. So what is he asking us? The exact center distance is asking us. So if you want the exact center distance, actually there is, this has to be divided by 2, I guess, right? So it's going to be into 2. So again here into 2, so this is going to be 300, and 3 times 300 is 900. These are the values. And when we go for approximate here as well, we have to go for 300. I guess even that is 300 by 8, 37.5. So either you go for 37 or you go for 38. So I guess 38 will be a better option, and that's what we will go with. So 38 times modules, so 38 times 8, 304, and the diameter 2, that is into 3 times 912 mm. This is mm. So now the exact center distance, that will be D1 plus D2, exact values of D1 by D1 and D2 plus divided by 2. So we get that as 304 plus 912 divided by 2. So 608. So approximate value here told is starting with 600 mm, but exact value it's going to be slightly different. That's coming out to be 608 mm. So I hope you have solved, I hope you have understood this particular problem, and most of the problems will be solved in the coming videos.